Welcome to the Republic of Technology, your ultimate destination for tech trends and insights. Stay tuned for more. Remember, in the Republic of Technology, innovation never sleeps.
Have you ever pondered the significance of understanding a DOL circuit and contactor principles? Today we'll delve into that. You see, DOL circuits or direct online circuits and contactor principles are not just some obscure electrical jargon. They are, in fact, the backbone of many electrical systems that power our everyday life. From industrial machinery to everyday appliances, these principles are at work, making our lives easier, safer, and more efficient. Understanding these principles isn't just for electrical engineers or technicians. It's for anyone who wants to enhance their problem-solving skills, increase safety, and gain a better appreciation for the marvels of modern technology. So whether you're a curious mind seeking to quench your thirst for knowledge, or a budding engineer eager to get your hands dirty, understanding the DOL circuit and contactor principles is a must. So buckle up as we take this electrifying ride into the world of DOL circuits and contactor principles. At its core, a DOL circuit is a simple yet powerful tool in electrical engineering. Now let's delve into what exactly a DOL, or direct online circuit, is. Picture a straightforward, efficient setup of electrical components. This is essentially what a DOL circuit encapsulates. It's a type of power circuit where the motor receives direct power from the main supply line. Let's break it down into its primary components. Firstly, we have the motor. It's the heart of the circuit, the machine that converts electrical energy into mechanical energy, setting everything into motion. Next, we have the switch. This is the component that controls the flow of electricity to the motor. When it's turned on, it allows electricity to flow, activating the motor. When it's turned off, it cuts off the power, bringing the motor to a stop. Lastly, we have a protection device. This is a vital part of the circuit as it safeguards the motor from potentially damaging electrical faults, such as overloading or short-circuiting. Now, let's talk about how it all comes together. When the switch is turned on, the motor is directly connected to the power supply. This is why it's called a direct online circuit. The motor starts up at full speed almost instantaneously. It's a bit like jumping into a cold pool. There's no gradual acclimation, it's 0 to full power in an instant. However, this sudden rush of power can cause a high inrush current, which is typically 6 to 10 times the motor's full load current. This can lead to mechanical stress on the motor and electrical stress on the power lines, which is why DOL circuits are generally used for smaller motors. Now what happens when the switch is turned off? The power supply to the motor is instantly cut off, causing the motor to stop. And throughout it all, the protection device is always on guard, ready to intervene if any electrical faults occur. And that, in a nutshell, is what happens in a DOL circuit. But hold on, we're not done yet. Now, let's shift gears and look at contactors. What are they and why do we need them? A contactor is a special type of relay that's used in electric circuits, primarily to switch on and off high-voltage electricity. It's like the traffic cop of the electrical world, controlling the flow of electricity and ensuring that it goes where it's needed most, and importantly, when it's needed. At its core, a contactor has three main components. First, we have the coil, also known as the electromagnet. This little guy is the engine that drives the whole operation. When an electric current passes through the coil, it creates a magnetic field that pulls in a set of contacts, causing them to close or open, depending on the design. Next, we have the contacts themselves. These are the gatekeepers, the ones that allow or prevent the flow of electricity. When the coil energizes, it pulls the contacts together, allowing electricity to flow. Conversely, when the coil de-energizes, the contacts separate, cutting off the electrical flow. Lastly, we have the frame. This is the sturdy housing that holds everything together, ensuring the coil and contacts can do their jobs without interference. So how does all this work together? Well, when an electrical current flows into the coil, it creates a magnetic field. This magnetic field then pulls the contacts together, allowing the current to flow through the circuit. When the current to the coil is cut off, the magnetic field collapses, causing the contacts to separate and interrupting the flow of electricity. It's like a well-choreographed dance, where every move is carefully timed and executed to perfection. This seamless operation of a contactor allows it to control the flow of electricity effectively, making it an essential component in many electrical devices and systems. It's like the heart of the circuit, pumping life into the system when needed, and slowing things down when it's time to rest. By now, you should have a good understanding of how a contactor functions. But how does it all come together? Now that we've got the basics down, let's see how the DOL circuit and the contactor work together. The direct online or DOL circuit and the contactor are like two peas in a pod. They both play crucial roles in electrical systems, and when they join forces, they form a powerful union. But how does this integration happen? Let's break it down. First, let's understand that the contactor is an integral part of the DOL circuit. It acts as a switch that controls the electric current flowing to the motor. It's like the conductor of an orchestra, dictating when the music starts and stops. The contactor decides when the motor comes to life and when it rests. Now picture a DOL circuit. It's a simple, straightforward wiring system that's most commonly used to start electric motors. In this circuit, the contactor is the star player. It's the device that directly connects the motor to the power supply. When the contactor receives a start command, it springs into action. The coil inside the contactor energizes, creating a magnetic field. This magnetic field pulls in the contactor's contacts, closing the circuit. And voila, the motor starts running. But what happens when the motor needs to stop? Well, that's where the contactor steps in again. Upon receiving a stop command, the coil inside the contactor de-energizes. This causes the magnetic field to collapse, and the contacts to open. This breaks the circuit, and the motor grinds to a halt. So in essence, the contactor acts as a gatekeeper. It controls the flow of power to the motor, allowing it to start and stop as needed. And it does all this while being a part of the DOL circuit, making it a key player in the electrical world. And there you have it, the DOL circuit and contactor principles in a nutshell. The next time you encounter them, you'll know exactly what's going on.